Hey everybody, today we're going to look at some of the AP multiple choice questions from the packet that you have, and we're going to go through questions 1 through 6, but really there's 7 of them because I messed up a little bit on the numbering. So let's take a look and jump in. So some of the vocabulary we've been talking about in Chapter 3, derivative, chain rule, product rule, quotient rule, logs, exponents, trig derivatives, definition of derivative, all stuff we're going to encounter in these multiple choice problems. Let's take a look. So first one, we got 3x squared plus 2xy plus y squared equals 2. They want dy dx at x equals 1. So we're going to have to plug 1 in. We're going to need a point to plug in there. So let's find our dy dx first. So we're going to have to use implicit differentiation on this. Derivative of 3x squared is 6x plus 2. Then we got to use product rule. So we have y plus xy prime, right? Because derivative of x is 1 times leave the y alone. Then we have plus x, and then we take derivative of y. Plus 2y y prime equal to 0, because derivative of a constant is always 0. Now we're going to get all our y primes together. So let's see here. So we got 6x plus 2y plus 2xy prime plus 2y y prime equals 0. Looks like we make our lives a little easier by dividing both sides by 2. So we have 3x plus y plus xy prime plus y prime equals 0. So now we get the y primes together. We got y prime x plus y. Let's move everything else to the other side. So we'll have negative 3x minus y. Now we divide, so we have y prime is negative 3x minus y over x plus y. So now we can plug in our point. We only have an x, so we need a y. So what are we going to do? Well, we're going to plug it into the function because it has to have both of them on it. So we got 3x squared, which is just 3, plus 2y plus y squared equals 2. Subtract 2 from both sides. I got y squared plus 2y plus 1 equals 0. So we factor that. That looks like y plus 1 quantity squared equals 0. So y plus 1 square root both sides equals 0. So y must be negative 1. So we have x is 1, y is negative 1. Let's plug that in. So we're plugging in 1 comma negative 1. And that would give us, let's see, negative 3 plus 1 on the top. And on the bottom we would have x plus y, which is, 0. Interesting. That's undefined. We can double check our work there, but it looks like we definitely have 0 on the bottom. So let's make sure that x plus y was right. The y prime came out. We had x plus y. Yeah, definitely looks like it is undefined. Cool, so we have a vertical tangent there. All right. So number 2. Number 2, they're looking for the equation for the tangent to the graph of y equals arc sine x over 2 at the origin. So that is 0, 0 for our point. We now need a slope. So the slope, y prime, so this is tangent, sine inverse. Same thing as arc sine, right? So it's going to be 1 over square root of 1 minus x over 2 squared, chain rule, times 1/2. And we're going to evaluate that at x equals 0. So that's going to be 1 over, well, 1 minus 0, that's not too bad. So square root of 1 times 1/2, so that's 1/2. So we have our slope, we have our point, so it's going to be y minus 0 equals 1/2 times x minus 0, or y equals 1/2 x. Now it looks like these are written in funny forms. So let's multiply both sides by 2. So we have 2y equals x. And then I guess let's subtract 2y, because it looks like that's going to give us a. So we have x minus 2y equals 0. Cool. Not too bad. All right, moving right along. This is the oops, I didn't put a number on this one. Sorry, guys. So the derivative of natural log e to the 2x. All right, a couple ways to do this. First, let's do it the way that you guys probably tried it first. So if you do the natural log of e to the 2x, our derivative there is going to be 1 over e to the 2x. And we got a chain, right? Notice a is just that. Yeah, they're trying to get people that don't know that you have to chain, right? So 1 over e to the 2x times the derivative of the baby function, which is e to the 2x. So we leave the e to the 2x alone. Then we chain again on that 2x. So we multiply by 2. E to the 2x is canceled. It is just 2. Now, that's interesting, right? It kind of seems weird. If you look at our original function, though, we can use a log property here, right? This is asking, what power of e do I have to use to make e to the 2x? Well, it's just 2x, right? The other way to think about it is move that 2x to the front using log rules. 2x times natural log of e. Natural log of e is just 1. So this is just 2x. So they're just asking for the derivative of 2x, which is indeed 2. Cool. All right, sine x equals e to the y. They want to know dy dx in terms of x. So implicit differentiation. We got 1 equal to e to the y times y prime. Now we are going to divide by e to the y. So we have y prime equals 1 over e to the y. They want it in terms of x. So I have to plug the e to the y. It looks like that is equal to sine x. So y prime 1 over sine x. So I just used this original equation I had. E to the y is sine x, so I throw it back in there. And that is what? Cosecant of x? E. There you go. Not too bad. F prime of x is negative f of x, and f of 1 equals 1. So notice we have e's in all of these because we know that if f of x is equal to e to the x, then f prime of x is equal to e to the x, which is the function itself. So it's close, but we need a negative in the front. So it looks like we need a negative baby up there to be able to make that negative happen. So if f of x is e to the negative x, something like that, then f prime of x would be e to the negative x times the derivative of the baby function, which is negative 1, which is negative e to the negative x. That is indeed the opposite of f of x. Now let's check to see if this works, f of 1 being 1. If I plug 1 in here, I get e to the negative 1, which is 1 over e. That definitely is not true. So it can't be e to the negative x, so it's not that one. But it's got to be something similar. It has to be something where there's a negative in the exponent, because that's going to give us that negative f of x when we get out. So let's try some of these other ones that would give us a negative. So this first one, that would give us a negative 2 over 2. Yeah, that's possible. So because if we do f prime, so if this is our function, then f prime of x would be negative 2 over 2 times e to the negative 2x plus 2, which is negative e to the negative 2x plus 2. That is indeed negative f of x. If we plug in 1, let's see what happens. If we plug 1 in here, we get negative 2 plus 2, that's 0. E to the 0 is 1 times 1/2. Nope, that's 1/2. That won't work. Let's try the next one. Derivative definitely would be negative e to the negative x minus 1, because the derivative of the baby function is negative 1. If we plug in 1, we get negative 1 minus 1. That's like negative e to the negative 2. That's not going to work. Let's try the next one. So definitely f prime of x would be negative e to the negative 1 minus x. Okay, so that works out. We get the opposite of the original function. We take the derivative. If we plug in 1, hey, 1 minus 0 is 0. E to the 0 is 1. Looks like C is our winner. Why doesn't E work? Well, the derivative for this one is just going to be negative e to the x, right? Because the negative is a constant. Forget about it. E to the x just gives you e to the x. So that's the original function back. It's not the opposite of the original function. And e to the first power is not 1. So that works out. All right, if f of x is x over tan x, they want to know f prime of pi over 4. Looks like we got to do some quotient rule. So f prime of x, low d high, tan x times 1, minus high d low, secant squared x, over the square low we go, is tan squared x. And evaluate that at x equals pi over 4. So tangent of pi over 4 is 1. That's going to be useful, right? Because pi over 4, that's where sine and cosine are the same value. So this is 1 minus pi over 4 times secant squared x. Secant of pi over 4 is 1 over cosine pi over 4. So secant of pi over 4 is actually root 2. I'm going to have to brush up on your unit circle to get that one. So we square it, we get 2. So that's 2 on the top. And then divided by tangent squared of pi over 4, that's 1 squared, which is 1. So this is 1 minus pi over 2. Is that here? Yes, E. Cool. I think we got one more. What is the slope of the line tangent to the curve y equals arctan? That is tan inverse of 4x. Same thing. Tan inverse 4x. At the point at which x equals 1/4. All right, so derivative of tangent inverse, y prime is going to be 1 over, it's 1 plus x squared, so 1 plus 4x squared, chain rule, times 4, because the baby function is 4x. All right, so now we're going to evaluate that at x equals 1/4. So that would be 4 over 1 plus 4 times 1/4, quantity squared. Well, 4 times 1/4 is just 1. So this is 4 over 2, which is 2. A. I think that's the last one we have in this set. So come back if you want to see the last half of those multiple choice problems. See you soon.